Okay, the warm-up, guys, says set U, which is talking about the universal set, consists of the elements S, O, P, H, I, and A. Subset B consists of A, I, and O. If set B is a subset of set U, what is the complement of set B? That's one way they could have asked it. Understand, on the state exam, sometimes they write it like this, the symbol, complement, or like this. So any one of these means complement. So make sure you understand those symbols, not just the word. Complement is all the elements that are not in the universal set. So what I would do is I would look at A, I, and O are in B. So cross them off in the universal. A, I, and O. So the elements that have not been crossed off are S, P, and H, which is S, P, and H, so that is the complement of B. Applications of linear systems. This is lesson 6-4. We're going to do actually 2 word problems, and we have to try to figure out which method is the best method to use out of the 3 that you have learned. Graphically is a great visual display. Sometimes, though, you have to actually do an estimate because you don't always, the lines that you graph don't always intersect at exact points. So even though graphically is nice because visually it looks good, sometimes it takes longer and sometimes it doesn't give you an exact answer. Substitution, which is the first algebraic method you learned, is good when one of the equations has already been solved for the variable, then some of the work has been done for you. Whereas elimination is nice because if they give you the 2 equations in the same order and one of the coefficients of one of the variables are the same number opposite signs, then elimination's kind of been set up for you as well. Know that either substitution or elimination are both algebraic methods that will work for you no matter how ugly or big the numbers become. So let's look at this example. It says, Julia went to the movies and bought 1 jumbo popcorn and 2 chocolate chip cookies for $5. Marvin went to the same movie and bought 1 jumbo popcorn and 4 chocolate chip cookies for $6. How much does 1 chocolate chip cookie cost? We actually, because this is a multiple choice question, we actually could work backwards. But let's pretend this is not a multiple choice question, and let's pretend this is a gridded or fill-in or an extended response question, and we actually have to show all our work and come up with the answer without guessing and checking. All right, let's start off with our let statements. Go ahead and let's let x, doesn't have to be x, but I'm going to go ahead and use x is going to be the number of the cost of popcorn. So the amount of popcorn and how much it costs. And then we're going to let y equal the cost of cookies. Now, if you set up 2 equations, which I'm forced to do because I have 2 different variables, we're going to set up an equation that represents Julia, and we're going to set up an equation that represents, I'm going to write them up here, Julia, and then we're going to set up an equation that represents the other person's name is Marvin. So Julia, she went to the movies and she bought 1 jumbo popcorn. So it's 1 jumbo popcorn times how much they are, plus she bought 2 chocolate chip cookies, so it's 2 times how much those are, and they totaled a total of $5. Whereas Marvin went to the same movie and bought 1 jumbo popcorn, which would be 1 jumbo popcorn times the cost, x plus 4 chocolate chip cookies, which would be 4 times the cost, y, and he totaled $6. If you look at the 2 equations that we've set up, they're both in standard form, and I would believe that elimination might be the easiest way to work. I would not do graphically because, especially looking at the answers, but anytime you're dealing with a real life problem, there's a very good chance you're going to end up with decimals for your answers, and graphically would be, it would make it that much tougher. So I'm going to do elimination. Even though you could do substitution, you'd have to solve for one of the variables if you chose substitution. But because they're already lining up for me, I'm going to go ahead and go with elimination. Now, by elimination, I've got to make sure that if I'm going to eliminate the x's, they have to have the same number, which they do, but one's going to have to be a positive and one's going to have to be a negative. Or if I did the y's, we'd have to get one to a positive 4 and we'd have to get the other to a negative 4. I'm going to go ahead and eliminate the x's. So I need one of them to be a negative x. So if I multiply this whole thing through by negative 1, my new equation would say negative 1x minus 2y equals negative 5. Don't forget to multiply all the way through, otherwise that will be a mistake that will mess everything up from that point on. The second equation you don't have to manipulate at all, just rewrite it. These guys cancel, that's why they call it elimination. 2y plus 4y is 6y. Whoops, it's not 6y. It's a negative 2y, so it's 2y is equal to negative 5 plus 6 is equal to 1. Divide both sides by 2, and you get 1/2, which is really equal to 0.5. Now, going back into the question, it says how much does one chocolate chip cookie cost? Well, chocolate chip cookie was y. So I've actually figured out the answer, and I actually don't have to go on and find x, even though I could, and if the question asked for both, you would go ahead and substitute your 0.5 back into one of your equations to find x, which is the cost of your popcorn. So that means that one chocolate chip cookie costs 50 cents, right here. All right, let's try another word problem. Two planes are traveling. One's traveling from the west coast to the east coast, and the other one's traveling from the east coast to the west coast. If you look at the wind pattern, this red arrow line in here, that's telling you which way the wind is going. So it's going to help the pilot over here go faster, and the North Carolina pilot is going to actually be going into the wind, which is going to slow them down. So let's go ahead and read this. It says a traveler flies from Charlotte, North Carolina to Los Angeles, California. At the same time, another traveler flies from Los Angeles to Charlotte. The airspeed of each plane is the same. Notice how they gave it to us right here for our let statements. So they let A equal the airspeed. So we're going to have to use the variables they're forcing us into. The airspeed of each plane is the same. The ground speeds are shown below. So the ground speed for the west to east coast plane is 550 miles per hour, whereas the east coast to the west coast plane is 495 miles per hour. The ground speeds are shown below. What is the airspeed? What is the wind speed? Now, the wind speed is W. So W, I'm going to identify that is equal to the wind speed. It says what is the airspeed and what is the wind speed. So we're looking for A and W, which means because I have two different variables, I have to set up two different equations. So let's set up an equation that represents the Los Angeles airplane. We'll call it the LA. That's going to be the airspeed, however fast he's going, plus the wind speed, and it's going to be plus because the wind is blowing behind him, so it's going to be a positive. It's going to help him and push him along, and he totals a ground speed of 550 miles per hour. Whereas the Charlotte pilot, he's got the airspeed, which is the same. However, the wind is going directly into him, so it's not helping him, it's actually hurting him, which means we have to write minus, and he ends up at a total ground speed of 495 miles per hour. If you look at these two equations, they look like they're set up for elimination. So that's what I'm going to go with because they are lined up the same. And not only are they lined up the same, but if you look at the wind speed, the W's, I don't even have to manipulate either equation. When you guys add these together, what's going to happen is your W's are going to actually cancel. So A plus A is 2A, and 550 plus 495 comes out to 1,045. Then what you need to do is divide both sides by 2. These guys cancel, and we get an airspeed of 522.5. So the airspeed is 22.5 miles per hour, and the wind speed is equal to, you take 522.5 and you add your W from your first equation. So we're going to take 550 and we're going to subtract 522.5. That's going to give us 27.5 miles per hour for our wind speed. And there it is. Don't forget though to do your checks.